Hello everybody, this is me again, Yusuf Sarh, chemistry teacher. Today we're gonna have the second part of section 2 and chapter 5, and it is rate law of reaction. What is the rate law of reaction? Rate law of reaction is simply a law that relates concentration of reactants with the rate. Concentration of reactants with the rate. So it involves the concentration of reactants each raised to a power equals its order. So what is order? First, let's see. Reaction law relates concentrations of reaction rate, of course, based on this law reaction. Rate law is directly proportional. Rate is directly proportional to what? To reactants concentration each raised to a power equals its order. What is order? Let's say the order. Order is the power to which concentration of reactant is raised to in the rate law. So we studied in the last lecture that the rate of a reaction is directly proportional to concentration of reactants. So we can based on this derive the reaction rate law. Let's go on and have an example here. We have in this reaction nitrogen monoxide reacts with hydrogen producing nitrogen and water. So because rate is directly proportional to concentration of each reactant, so it is directly proportional to molar concentration, of course, we mean, of H2. The brackets here means molar concentration. The brackets here are molar concentration. And also, of course, this is raised to a power, suppose it's n or x or whatever. And at the same time, the rate of the reaction is directly proportional to what? To concentration of nitrogen monoxide, which is one of the reactants. This is also raised to a power equals m. What is the role of these powers? These powers or these orders show the effect of increasing or decreasing the concentration of each reactant. Sometimes the effect of increasing concentration of one reactant is greater or lesser than other reactant, and some reactants, when we change their concentrations, no effect on the rate. So here we have the samples. R is the rate of reaction, N and M are the orders in respect to the reactants, the nitrogen monoxide and hydrogen. And K we will study later is the constant or specific constant of rate law. Let's move forward and see how can we decide the values of N and M. Okay, let's go forward. Sorry. Okay, how to decide N and M? In order to decide values of N and M, we cannot conclude it from the reactions equation. Why? Because we need a registered data. This data taken from experiments, of course. So we need experiments in order to decide the effect of changing concentration of each reactant on the rate law. So we have some details here. For this example, we have R is directly proportional to hydrogen raised to N times concentration, molar concentration of N, or raised to M. Now, from experiments, it's found N equals 1 and M equals 2. So overall order here, overall order, which means the order of the reaction equals n plus n. So this equals, we have 1 plus 2 equals 1 plus 2 equals 3. So the order of this reaction is overall is 3. Now let's see some notes here. Values of N and M must be taken from experimental data and cannot be taken from the chemical equation. This is the number one, not number one. Sum of orders or powers, M plus M, is the reactions order or the overall order. And this reaction, it is 1 plus 2, so it is 3. Reactions overall order, which means the reaction order cannot be greater than 3. It can be 1, it can be 2, it can be 3, but not greater than 3. When changing concentration of the reactants doesn't affect the reaction rate, the order of the reactant will be 0. It means that its concentration change doesn't affect the rate. This is important. When change of concentration of a reactant doesn't affect the rate, which means it would not be involved here, but here we have it does. Here we have it does, so both are present. One has order of 1 and the second has order of 2. Okay, let's move forward and see. When increasing concentration of a reactant causes an increase in concentration rate by the same ratio, from here is very important. From here, when doubling, when increasing, here important, IMP. Okay, the importance here of the points we will talk about now, because by following these notes, these rules, we will not need to have a long calculations that present in your textbook. Of course, you're going to solve some problems by the technique in your textbook, but it's easier to follow the points here, starting from here. So we have, when increasing concentration of reactants cause an increasing reaction rate by the same ratio, which means when doubling concentration of a reactant and keep the second constant, if it causes increasing the reaction rate by the same ratio, which means doubled and the rate also doubles, this means the power or the order of this reactant is 1. And this is exactly the previous reaction for hydrogen. Hydrogen has an order of 1, which means doubling concentration of hydrogen and keeping concentration of N or constant causes doubling rate, which means order is 1. This is 1. Second, when doubling concentration of a reactant causes fourfolding reaction rate, the order here will be 2. The order here will be 2. Let's be back to our the reaction that we saw here. Okay, the reaction here was H2 plus NO yielded, okay, we have H2O plus N2 plus N2. Of course, this is not balanced, so we have here 2, we have here 2, and also we need here. Okay, here the order of H2 is 1, which means when concentration of H2 is doubled and this is constant, rate is doubled also. So when keeping concentration of N or constant and this is multiplied by 2, this makes R also doubled, which means the rate also doubled. You see, doubling concentration of one reactant doubles rate, so the power is 1. Okay, what about the second? The second one, here we have the order is 2, which means when we keep this is experiment 1, suppose this is experiment 1 and 2, so suppose here we have the second. So when keeping this constant and this is doubled and this change in concentration of NO make R 4-folded, which means times 4. We know that 4 equals 2 power how many? 2 power, of course, 2. So we have multiples of rate equals multiples of concentration raise it to a power equals its order. Because 4 equals 2 to power m, for example. So m equals what? M equals 2. That's why the power of MO is 2. We have a rule here. We're gonna follow it and we can use it for all reaction rate laws that follow. So let's go forward and see. We have a rule here. This rule says multiples of rate equals multiples of concentration, of course, of one reactant, and the order, of course, there is to an order. So when we doubled concentration of NO, the reaction rate 4-folded. So we have 4 as multiples of R equals, 4 is multiples of rate equals 2 is multiples of the concentration of NO. Power to how many? To M. You see, this 4 is multiples of rate, and this 2 is multiples of concentration of NO, and the M is the order. So in this case, M equals how many? Equals 2. Why? Because 2 power 2 power 2 equals 4. And this is exactly what's present here. Multiples of rate equals multiples of concentration divided by the order. So what is the order here? Of course it is 2, because it makes the right side equal to left side. Let's see other notes here. We have when tripling concentration of reactant causes tripling reaction rate, which means by the same ratio, triple and triple, of course the order will be 1. And when tripling concentration of when tripling concentration of reactants cause 9-folding. Of course, 9 equals, this is the multiples of rate equals 3 power to n, for example. So 9 equals 3 power to 2. So n equals how many? N equals 2. So, which means if the concentration is tripled and the rate also tripled, the power is 1, because 3 equals 3 power to 1. But when tripling the concentration of reactant 9-folds the rate, in this case the power will be 2. What about if the tripling concentration causes 27-folded the rate? Of course, 27 equals 3 power to 3. So the order of this reactant is 3, and this is rare, but this is rare. Okay, we have another case. If doubling concentration causes 8-folding the rate, so 8 equals 2 power to 3. This also means that the order of this reactant is 3. Okay, we just said that we can use this general rule to find the order. Of course, the multiples of rate can be taken from the experiments will be given in the question, and the multiples of concentration also will be given. Now let's move forward for more practice. We have a note here. Sorry. If the reactant appears in a chemical equation but did not include it in the rate law, the order of this reactant is zero. The order of the sometimes changing concentration of one reactant doesn't affect the rate. So this reactant will not be involved, will not be included, will not be written in the rate law. Why? Because already it doesn't affect its concentration change, doesn't affect. So we have an example here. Okay. In the reaction below, carbon dioxide, sorry, we have carbon dioxide plus, nitrogen dioxide plus carbon monoxide yields nitrogen monoxide and carbon dioxide. Rate law is R here equals K, the constant of the specific constant of rate law, times NO power to 2, which means when doubling this reactant concentration, the R is fourfolded. Why? Because 4 equals 2 power to 2. But when doubling or even tripling or decreasing the concentration of CO, which means it doesn't affect the rate. Why? Because already not included here. We don't have CO here. So the order of CO is 0, and anything with order or the power of 0 equals 1. One multiple of any variable equals the variable itself or same amount. So this is an example in which the reaction rate not being affected by one reactant's concentration, but the order of 2 we have for concentration of the reactant nitrogen dioxide. So when doubling the concentration of NO2 causes fourfolding, and the rate will be times 4, fourfolding the rate. Okay, let's move forward and see what we have more about it. Okay, we can answer for the following. Determine order of CO. Of course, the CO doesn't affect, that's why it is 0. It is order is 0, so it doesn't affect, and has order of 0 and not included. By decreasing concentration of NO2, how does the reaction rate change? We said that reaction rate here R equals K times NO2 and the power is square. Because K is constant, so we're gonna remove the K. We will say R equals, the question says B, by decreasing NO2. Of course, the reaction rate also will decrease. Increasing NO2 increases rate, decreasing NO2 also decreases rate. C, how does increasing concentration of CO affect the reaction rate? CO is not involved in the rate law. Why? Because it doesn't affect, and its order is 0. So here we have no effect. Here we have no effect. But here in B, decreasing concentration of NO2, here decreases rate. Okay, what do you suggest to increase reaction rate 9 times? 9 times. So we have R equals K times NO2 square and multiples of R equals multiples of NO2 power 2. So we have 9 equals x to 2. So what is x? Of course, x here equals 3, which means in this case, in order to increase the rate of the reaction 9 times, we need to triple. We need to triple concentration of NO2, because simply it is power to 2 and 3 power to 2 and 3 square equals 9. Okay, that's all about this practice. Let's move forward and see, let's see what we have more. Reaction rate, these are the answers for the, we have a question here. Okay, and the reaction below 2A plus 2B yielding 4C, we have the rate law is K times A square times B, and the power of B is 1. Even if you see 1 is not written, but the B present in the rate law, which means its power is 1. Its power is 1. Find overall order. Of course, overall order here equals 2 plus 1 equals 3. The overall order also called the reaction order. Second, find order in B. Okay, the order in B is 1 because it's already present, which means doubling concentration of B doubles the reaction rate. Okay, let's move forward. When concentration of A decreased to half and concentration of B is 4-folded. Okay, let's write the reaction rate again. We have the reaction rate equals K times A. A is has order of 2 times B concentration, and it's order of 1. As we said, K is constant, so we're going to ignore it. We will say R equals A is cut to half. Okay, we have half, and this is square, times B. What is B? B is increased 4 times, which is 4-folded. 4. And the power of 4 is 1. So we have square of half. Half times half is 1 by 4. Times what? Times 4 equals 1, which means the reaction rate doesn't change. The reaction rate will not change here. Why? Because we have R, final R equals the initial R, because we're going to consider the initial R as 1 molar per second. Here also will be 1 molar per second, or even per minute, so it doesn't affect. Okay, let's move forward and see more practice. So K times 1, so we have just talked about that it doesn't change. We have not here if the question involves doubling or tripling or fourfolding the concentration and asked to find change in reaction rate. If the question involved decreasing concentration to half, to third, or to fourth, and asked to find the change in reaction, just follow the following. We have the multiples of rate equals multiples of concentration, and power, the power is the order. Just like the procedure or the technique we used in last example. We reached K. What is K and how to find K and what is unit of K? K in the beginning called specific rate constant or specific constant of rate law. Both are correct. So K, when powers or orders of reaction found, value of K can be found from an experiment, one experiment. So we have the concentrations, we have the rate, we can find the K value. Value of K is constant for a given reaction and differs for different reactions. When concentrations change, the value of K will not change. The value of K will not change. But when temperature changes, it would. when temperature changes. Here we have value of K doesn't change when concentration and pressure changed. Value of K increases when temperature increases. Why? Because the rate will be increased, and this constant also will be increased. Value of K increases when catalyst present. Why? Because catalyst increases the rate of reaction. And we have the unit of K. This is extremely important. Unit of K depends on the reaction order, which means overall order, and we have here if the reaction order, which means overall order reaction, is 1, if the order here, if the overall order is 1, the unit of K is second power to negative 1, or 1 by second, the same. If the overall order is 2, the unit of K is molar, negative 1 power to negative 1 times second power to negative 1. And if the overall order is 3, the unit of K is molar power to negative 2 times second power to negative 1. Okay, we have another example here, another question, here. How to determine a rate law and overall order when table of experiment is given? Okay. Just read the table carefully and find 2 experiments in which concentration of one reactant is changed and concentration of the second is changed. Use these 2 experiments to find the order of the reactant that experiences a change in concentration. Okay, now let's have an example here. Choose 2 experiments involving change in concentration of one reactant and constant concentration of the other. So you can find from these 2 experiments the order of the first reactant that changed. Second, we have here divide rate law of one experiment by the second to have the experiment with the greater value on the upper part. It's better to have the experiment involves the higher rate in the numerator. So cancel K because K is constant. We have repeat the steps 2, 3, and 4 for the second reactant. This procedure, this technique is written in your book. We're gonna solve some problems by following this technique. But the points, the rules that I told you in the beginning of this mini lecture will be useful, and if you apply them, let's say accurately, you will not need this technique, because this technique is a little bit long and can lead you to some mistakes. So let's have an example about this technique and apply the points that's written here. We'll be back to this again. Let's have an example involves okay. We have this question from chapter review. In the reaction 2A plus B yielding C, 3 experiments have been made. Experiment number 1, 2, and 3. And we have 2 reactants and we have the rate. In the first 2 experiments, concentration of B is changed, which means this is multiplied by how many? By 2. What about the rate? From 1 to 2. It is 2 to 8. 2 times 10 power negative 4. But it became 8 times 10 power negative 4. Which means it's multiplied by how many? By 4. Of course, you know that 4 equals 2. 4 equals 2 power to n. N means here equals to how many? To 2. So we can predict that order of B is how many? Order of B is 2. Let's move to find the order of A. We're gonna choose the 2 experiments in which B is constant and A is changed. This is multiplied by how many? By 2. Okay, from experiment 2 to 3. We can convert this 1.6 times 10 power to negative 3. We can write it as 16 times 10 power negative 4 for ease. And we know that 16 twice as 8. So this is multiplied by how many? This is multiplied by 2. So you can see that when concentration of A doubled with keeping concentration of B constant, the reaction rate also doubled. So the power of A is 1, the power of B is 2. We can predict that R equals K times A, its power we said 1. If not, it is also correct. B and its power is square. Let's follow the technique of your textbook and see if we will have the same result or not. Okay, now let's move forward and see the solution based on your book's technique. We're gonna choose 2 experiments, experiment 3 and 1, in order to find order of A. Why? Because in experiments 3 and 1, okay, here we have A changed. I will have here 2 and 3, sorry. This is constant and this is changed. So we're going to divide what? Divide 3 by what? By 2. 3 by 2. Okay, 3 by 2, 16 divided by, because this equals 16 times 10 power negative 4, so this equals 2. So the order of A is what? The order of A is 2. Let's move forward. Okay, we found that order of A, which is N, is 2. Now let's find B. B in experiment 2 and 1, B changed, but A is constant. So we have rate 1 by rate 2, 8 times 10 power negative 4 divided by 2 times 10 power negative 4 equals 0.4 molar divided by 0.2 molar. This equals 4. And this equals 2. 2 power to how many? To N. So what is value of N? N equals 2. So we found that order of A is 1 and order of B is 2. The same result if we follow the points that I told you in the beginning. If the concentration of any reactant doubled and rate doubled, which means the order is 1. It's just like A here. And if concentration of any reactant is doubled and rate is tripled, so the order is 2. This is the order of B. Let's see the result now, if it's compatible. Oh, sorry. Okay, so the power of N, the power of B is 2 and the power of A is 1, and this is exactly fit to the points that we mentioned too. Let's have one more example and finish this mini lecture. Okay, what about the unit of K? The unit of K. Okay, how can we find K? Overall order, we have it. Second, calculate the value of K. Value of K, because we have the rate law. Okay, this is the rate law. We can use it and use one experiment. Let's see the experiments here. We have the experiments here. So we can choose any one of these experiments. For example, this experiment. and apply it to find the value of k. So you will say, k equals r divided by how many? By concentration of A, its power is 1 times concentration of B at its power is squared. So an experiment of these will be useful. So let's use experiment 1. In experiment 1 we have R equals 2 times 10 power 2. 2 times 10 power to negative how many? Negative 4 divided by concentration of A is 0.2 and its power is 1 times concentration of B is also 0.2 and its power is squared. Okay, so let's finish here. We have 2 times 10 power negative 4.1. Power 1 is also 0.1 and 0.2 power 2 is 0.04. So we have here 0.2 times 0.04. So we will have here 0.0004 divided by 0.2. 2 times 4 equals 8, and we have the 3 digits after the decimal 0.008. So this equals this will equal how many? This will equal half, 0.5. What is the unit of K here? The overall order is the 3, so it is molar negative 2, it's molar negative 2, molar negative 2 times second negative 1. So this is the value and the unit of K. As we said, in order to find K, first you need to find the rate law and determine the orders of concentration of A and concentration of B. Later choose any experiment, number 1, number 2, number 3. And K equals R divided by concentrations of reactants, each placed to a power equals to its order. The unit of K depending on the overall order. Here overall order is 3, so the unit of K is molar power to negative 2 times second power to negative 2. This is all about today's mini lecture. I wish you could benefit from it and wish to meet you again on next mini lecture. Have a nice day.